Subscribe to the channel.
So, you want to be a software engineer. You want to type your way through the technological barriers of today and have the analytical mind to do so. Let's debunk the public myths of what it means to be a software engineer and give it to you straight. This is the reality of software engineering. We'll start with some context. What exactly is software engineering? You might be surprised to learn that it is not computer science, so let's clarify the difference. While both of them do have programming languages, concepts, and techniques at their core, computer scientists use these topics to do theoretical research and develop new technologies. For example, it was computer scientists that introduced the very first AI to the world back in 1956. Software engineers, on the other hand, apply these same programming skills to develop deliverable products, resulting in everything from the ChatGPT web application to the smooth experience of your RGB keyboard and PS5. Pretty cool, right? But what do they actually do? Starting with the absolute basics, all software engineers type lines of code into an IDE, like Visual Studio Code. This coding environment executes code to accomplish a goal. This could be as simple as printing out "Hello World" to the console, or as complex as applying quantum computing to already convoluted space missions. Bringing it back down to Earth, software engineers typically create and enhance algorithms, websites, apps, communications, cybersecurity, signal processors, and so much more. The range of applications are so vast, it's best that we run through a few examples to show you what they do instead of trying to explain it. But before we dive into the impressive careers of software engineers, we'll explore the university coursework that prepares these engineers to devise such innovative products. First, we need to note that software engineering is not a typical engineering field. But why? Maybe because they only work on computers? Although true, you might be surprised to learn that a staggering 27% of software engineers are self-taught. This number is primarily due to the accessibility of coding, as anyone can hop on the web and have an executable program in minutes. No matter if you plan to take this route and grind through the homegrown process, or if you take the university track, these courses will show you exactly what companies expect from an entry-level coder, so make sure to listen closely. The SE curriculum track can be divided into three main areas of focus: introductory topics, software foundations, and elective courses. A quick note that each university structures their curriculum a little bit differently, so don't get concerned if you don't see the exact track that your university offers. Now let's get right into it. First, the introductory topics will throw you into Calculus 1 through 4, your choice of a chemistry or physics series, and the basic introduction to coding classes. You'll also find yourself in statistics, linear algebra, and discrete math courses, which may or may not be useful in your career later on. This is also when you'll take your first real software courses, dropping you right into the jungle with Java, Python, C++, and similar languages. We highly recommend that you start building healthy coding practices right off the bat. You'll thank us later. But now it's time to roll up your sleeves and get to work. We're entering the software foundations. Here you get a taste of all the different flavors of software engineering, building a general understanding of the field so you can confidently choose your software concentration later on. We'll start with the good old computer organization, architecture, and networks. These bring you up to date on all of the computer need-to-knows: CPUs, memory hierarchy, user input and output, and more. They'll also lay down the basics of computer data pipelining and how to communicate with other devices like keyboards, routers, and even other computers. You'll also get to dive into data structures and algorithms, which are all about searching, storing, sorting, and manipulating the number one most important thing in our digital world: data. If you couldn't guess, these classes are very important. Many even say they were the most useful in the entire degree. To raise the stakes even more, it's almost certain that your interviews will pull a lot of content from these classes, so make sure to absorb as much as possible. Beyond that, you'll also explore the ones and zeros of the computer engineering world. You'll tap into digital logic, assembly language, and hardware that supports everything in our software-defined world. This is the first and last time you'll lean into the hardware stratosphere, unless, of course, you decide to continue the track later. Oh, and everyone always loves this next part. You'll also get to explore the ever-popular website, app, and operating system development with a UI and UX focus, usually with a team of other students. This is not only super popular classes, but also one of the most common ways for entry-level developers to break into tech. Not to mention, you're learning very sought-after skills, as 73% of small businesses have their own website. Did somebody say side hustle? Now, at this point, you've sampled the field, been around the block, and have a strong baseline of understanding in all the major foundational software subjects. But don't get comfortable yet. There's one level left: your elective courses. In this final stand, you reflect on which of the past classes you've enjoyed the most and could see yourself starting a career in, picking one, maybe two concentrations to focus on and pursue further. And with that, you finally typed your way through the long and rigorous path of all-nighters, linked lists, and never-ending while loops to reach the breathtaking summit of your degree, your capstone design course. Here, you team up with other engineers to complete an entire engineering design process from scratch. You'll run into all types of real-world scenarios: limited computing power, learning a new language on the fly, protecting your product from cyber attacks, and even unexpected conflict resolution between team members. It is a model of the real world, after all. If you're curious about some of the project possibilities, we've seen students working on satellites, building smart robots, and partnering with local companies to create software applications for them. Anything flies as long as you're using the skills you've learned over the last 4 years and creating a marketable product. The only rule we'll give you is that you must pick a project that enhances the skills that you plan to use in your career. After all, this project is effectively the transition from university to your career and a huge talking point in all of your interviews. But how could you possibly be expected to pick a career without knowing what's out there? Well, great question. Let's examine a few software engineering fields, their outlook, and famous salaries. But be careful to not get lost in the dollar signs. You don't want to miss our fan-favorite pros and cons right after. Getting back to it, we'll start off our job search with the AI and machine learning field that is absolutely popping off right now. Everyone wants in. But for you, this means a lot of stiff competition. Though you should know that with hard work and dedication, you can achieve anything, especially breaking into this field. If you're passionate about automation, advancing computer vision, and good with math, then artificial intelligence could be the perfect niche for you. You'd also be happy to find that in the US, machine learning engineers are paid a whopping $135,000 to $160,000 on average. Next, let's take a look at cybersecurity. We don't expect you'll run into any firewalls getting into this field. This is especially true if you have a knack for hacking and the skills to back it up. We say this because a huge part of the job is white hat hacking, hacking into your own safety infrastructures to identify and improve the weak spots. These engineers are to thank for protecting everything from your smartphone photos to the entire population's social security numbers and government databases. Cybercrime is also, sadly, on the rise, leading to all types of software engineers being expected to dabble in cybersecurity. As you might guess, the market for cybersecurity engineers is only getting bigger, and in this growing field, engineers are aptly paid an average of $125,000 a year. But what if you're more interested in app and website development? We all use apps, we all visit websites, might as well apply this experience to the field, right? Absolutely yes. This is a very popular route for a lot of entry-level engineers, and if you can see yourself enjoying it and have the drive, we say go for it. Front-end, mobile app, and back-end developers can expect to make an average of $111,000, $133,000, and $160,000 per year in the US. Although entry-level salaries will be closer to $85K, $100K, and $115K a year. Now we'll take a quick look at career paths on the hardware side of things, specifically programmable logic, embedded systems, and digital signal processing engineers. In one form or another, all of these engineers develop programs that react to and/or control electrical components. This could be updating the view in the Apple AR headset as someone looks around the room, positioning thrusters as SpaceX attempts to land their latest Starship, or simply flipping a few switches from signal receiving to transmitting on a tactical radio. PL, embedded, and DSP engineers make an average of $102,000, $135,000, and $139,000 in the US. Sadly, we don't have the time to get into more software job markets or go into great detail, but let us know if there's something you want us to cover. We'll do our best to get on it right away. Now, it's time to answer the real question. You have a solid understanding of what lucrative and stimulating software careers are out there and know exactly what it takes to build up to that point. But will you actually want to be a software engineer? Thankfully, our software engineers have developed a pros and cons list that best reflects the field so that you'll have everything you need to confidently answer that question. Now, without further ado, let's get right into it. Kicking off the cons, these engineers are known to have exceptionally long hours and regularly work in high-pressure situations. I mean, you didn't think all that pay came from a simple if-else statement, did you? Now, of course, this varies from company to company, with each falling somewhere on the stress and pressure spectrum. If this worries you, you'll simply just need to ask about the company culture before agreeing to a job. They are not only interviewing you here, you're interviewing them to see if you want to work there. Our second software con is the real issues that come with extended periods of sitting at a desk. Some companies supply you with a standing desk, which definitely helps. But a career of mostly unchecked sitting and staring at a monitor are linked to all types of body pain and eyesight degeneration. Another downside is the technical competition. Because software engineering is so accessible and can lead to many different forms of success, there is a large pool of competition elbow jabbing for the same positions that you want. This leads to tough competition getting into universities and breaking into the job market. However, don't let this deter you. We have proven methods to help you stand out amongst the crowd and achieve whatever you want in engineering. Subscribe so you don't miss out on them. The final not-so-great things some say about software engineering are that you typically will have to collaborate with a team, constantly solve very challenging problems, and keep learning for the entirety of your career. But actually, many engineers consider these the coolest and most stimulating parts of the job. Getting into the positive side of software engineering, everyone loves the opportunity to work from home. You're almost guaranteed the option of hybrid remote work or full-time remote work in this field. All you need is a laptop and Wi-Fi, and you're good to work wherever you want. Another cool part about software is how flexible the product is. For example, you can take a finished program, add some parts here, take some time out there, and simply try it out. If a civil engineer tried to do this with their finished product, well, it wouldn't exactly go as well. Further, this is an ever-growing industry with new job opportunities popping up left and right. There are approximately 175 new websites created every minute. AI and augmented reality are pushing the boundary of what everyday life with tech looks like, and you have all the tools you need to start your own multi-billion-dollar company to capitalize on it, right from your garage. As you know, there is also the salaried pay, which is bountiful. After all, the average software engineer brings home a base pay of $142,000 a year, 28% above the national average in the US. But arguably, the best part of software engineering is the surge you feel after crushing yet another project, knowing that you're genuinely contributing to the technological prowess of humankind, and doing so with nothing but the power erupting from your fingertips. Now, with all this in mind, would you become a software engineer? We want to give a huge shout out to our team of software engineers that helped make this video. If you liked it, check this out to learn more about software engineering and get started programming today. Don't forget to subscribe for more insider engineering knowledge. See you next time.